Okay, so notes 4 is conducting a significance test for proportions. So in this notes, we're actually going to not only set up our significance test, but also solve for it. And we'll have an example FRQ at the very end. So it says importance, significant test notes. So the p-value is the conditional probability. It assumes the null hypothesis is true. Assuming H naught is true, the p-value measures how likely it is to get evidence for the alternative hypothesis. So is it as large or larger in the direction of the alternative by chance alone? Okay. You must name the test either by writing down the test name. And what's the test that we're doing in this unit? Like the big inference test for the whole unit. Perfect. And we can shorthand that and say 1 proportion z-test. So again, the whole name is 1 sample z interval for proportions. And this is the shorthand 1 proportion z-test. Or we can write down the generic z formula. Remember, you have to include one or the other in your calculation section of your FRQ to get points. For a hypothesis test, we check n times p naught is greater than or equal to 10, and n times 1 minus p naught is greater than or equal to 10. Which condition is that? The large counts. Okay, remember the 10% condition is checking if the sample size is less than or equal to 10% of the population size. That's the little n less than or equal to 0.1 of the big N. Okay, so that is for hypothesis tests. And for confidence intervals, we check if n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. It's still the large counts, but what's the difference? So for hypothesis tests, we use that p naught value, okay? That is that claimed proportion. And for confidence interval, we use the p hat, which is the estimated proportion, okay? When there is not convincing evidence to reject the null hypothesis, it does not mean there is evidence that the null hypothesis is true or the alternative is false. So remember, what is the opposite of rejecting the null hypothesis? Fail to reject the null hypothesis. Do we ever say we accept the null hypothesis? No. What happens if you do? All wrong. And I'm going to give you a 0. Right? We don't say accept the null hypothesis. That's a big no-no. Okay. And we need to remember also, when do we reject the null hypothesis? Good. Good. When the p-value is low, we reject that hoe.
Yes, we do.
See, I knew you guys would, right? Okay. Now we're going into how to conduct a significance test. We're still going to use the 4 C's. What's the first one? Communicate. So when we communicate, we're going to make sure we define P in words. So it's always going to be part of our problem. It's always going to be P is the proportion of da-da-da-da-da, whatever the problem is about. Then we're going to identify the hypotheses and then write down your significance level. Okay, what is the variable for significance level? Not A, but we call it alpha. Okay. What's the second C? Good. You could say create or conditions. Okay, so now that we're towards the end of the course, we're going to use conditions more than create because we are trying to prove or disprove certain conditions. That's why we call it conditions. Okay. Remember, our 3 conditions are random, independent, and normal. And within each of those, you have to use a certain condition, like 10% or large counts. What is our third C? Calculate. So when we calculate, we have to either identify the inference. So what's the name of the inference again? 1 proportion z-test. Okay, so you have to either name the inference or write the formula. So you could write this formula for the z statistic, which is z is equal to p hat minus p naught over the square root of p naught times 1 minus p naught over n. Okay, which one's easier to remember? The inference name or the equation? The inference name. Okay, use the inference name. Okay, or you could write the equation in words. So remember I said this is a special type of equation where they write it in words on the formula chart because there are different types of statistics and different types of critical values. And remember that is statistic plus or minus the critical value times the standard error. Okay? So if you can't remember this formula, you could remember how to write it in words, or just look on your formula chart because this is on your formula chart. Okay. Yes. But to be extra cautious, I would also write the name, right? Still write 1 proportion z-test. Okay. The last part of calculate says find your p-value by calculating the probability of getting a z-statistic this extreme or more extreme in the direction of the alternative hypothesis. Okay, cross off that last little part because we're not using the TI-84. On Desmos, we use the standard normal. Okay, standard normal distribution. Okay, and then what is the last C? Conclude or conclusion. Okay, and then again, it gives you this nice sentence stem that you are just going to replace those words that are in those brackets. Okay, so it says because our p-value of, you write what your p-value is, and then either if it's bigger or smaller, then our significance level of, and remember significance level is alpha, we either reject or fail to reject the null hypothesis, which means we either do or do not have convincing evidence for the alternative hypothesis. So if we reject, that means we have evidence or we do not have evidence. We have evidence. So if we reject, we have convincing evidence. Let's color code it. If we reject, we have convincing evidence. Okay? If we fail to reject, that means we don't have convincing evidence. So whatever you say first is going to help you write your next sentence. So if you reject the null hypothesis, you do have convincing evidence. Okay, you have to have enough evidence to reject something. Okay, failed to reject means we can't reject it, which means we don't have enough evidence to continue. Okay, any questions on the 4 C's? Okay. So this next part, the last part of the notes, is going to give us an example FRQ. Okay. You are going to use the setup that we use on the notes here to answer your homework problems. Okay. So this is where I would write kind of small. Okay. If you need to, if this helps divide up your space, put boxes here. Okay, so communicate, conditions, calculate, conclude. Just how it looks like on your homework where it gives you the boxes. Okay, if you're someone who feels like you're going to write too big. Okay, again, up to you. So the first thing I'm going to do is read the problem. It says, Alan reads a report that says 80% of U.S. high school students have a computer at home. He believes the proportion is smaller than 0.8 at our school. Alan chooses an SRS of 60 students and records whether they have a computer at home. He wants to test this at a 5% significance level. In his sample, 41 of the students have a computer at home. So, where it breaks it up in part A, typically this is part of your original FRQ statement. It says, is this evidence that the proportion of students who have a computer at home is less than the national proportion? For this question, are we going to say yes and no? No, this is your cue to start doing the 4 C's for your FRQ. So, communicate. Do we write the 4 C's on our paper? Yes. Yes. Write the 4 C's on your paper. Yes. Okay. It could mean the difference between a point or two. Okay. Remember, the more organized, easier to read, the more the grader is going to believe that you understand what you're talking about. Okay. Versus having to go guess around and kind of look to see where things are. So communicate. We're writing our 4 C's. So the very first thing we're going to do is we're going to define P. So P is equal to, and remember, we always write proportion as our first word, and then the rest comes from the problem. So this is the proportion of what?
U.S. high school students that have.
Perfect. Proportion of U.S. high school students that have a computer at home. Okay, again, we found that directly from the problem. The next thing we're going to do is write our hypotheses. So always start off by writing H naught and HA. Okay. Just because when we're writing our hypotheses, I don't want you to get the confusion of saying H naught is equal to some value. Because then you're forgetting the p-value, the proportion, which is very important. So remember, our null hypothesis is always going to be P equals, and then whatever the original claim is. So what's our original claim? 0.8. And where was that original claim found? Where in the problem? No, not quite. Where did Alan find this null hypothesis? In a report. This is the claimed. Okay, that's this part. I'm going to color code. Okay, the alternative is not what Alan found, but it's what Alan thinks. And what does Alan think? Less than. So this is where we do P is less than 0.8. And that's where this part would come in. The proportion is smaller. That's what he thinks. Okay, the original claim is found in something. In this case, it's a report. Okay, the alternative is what Alan thinks, his own opinion. And we're trying to prove or disprove his opinion. Okay, so that's the next part. From here, you're then going to write alpha. Okay, so based on the problem, alpha is equal to 0.05 because alpha is the significance level, which says it's 5%. Okay. Then we're going to write N. What's N? It's 60, right? Because N stands for the random sample that he chose. He chose 60 students at his school. Okay, what does 41 represent? The ones that have it. So we're going to use that 41 when we find P hat. So P hat is 41 over 60, which is 0.683. Okay, 41 is how many people had a computer. 60 is how many people he had answered that question.
Is that a 68?
0.683 at the end? Yep. Okay, so that's communicate. Okay, just in the communicate part, you just got about 6 points. Okay? 1, 2, 3, 4, 5, 6. That's 6 points. Okay. After communicate, we do what? Conditions. Are we writing conditions? Yes, please write conditions. Okay, let's see. Group 7. What are our 3 conditions that we're trying to prove? Yes. No, not large counts. Independence. Normal and random. We write those. Random, independence, or independent, and normal. Okay, you have to write them down. It is not enough for you to say 10% condition, large counts condition, etc. Okay. From here, then we go back into the problem and see what we can use to prove these. So for random, what in the problem can we use? The SRS, and that's all we have to write. Because what does SRS stand for? Simple random sample. Okay, that means they did a random sample of 60 students. Okay, for independent, which condition are we using to prove independent? 10%. So you need to write the 10% condition or the formula. Okay, either one, so you can do this. Okay. Is that enough just to write the condition? No, I have to then do what? Plug in my values. I got to do the math portion of it, okay? So N we said is 60, so this is 60 less than or equal to 10% of, and are we given our population size? No, so what do I have to do? Write it in words, and what are going to be my words here? Good, all U.S. high school students. Okay, is that a safe assumption? Yes, I would say there's more than 600 U.S. high school students. Okay, then we go to normal. And what condition is used to prove the condition normal? Large counts. I'm going to write large counts condition. Okay, or you can write the formula. This is N times P naught greater than or equal to 10, and N times 1 minus P naught greater than or equal to 10. The only thing about this is, remember, we had a large counts condition formula for significance and one for confidence interval. If you were to put N times P hat, which is for confidence interval, as your formula for the large counts conditions on the normal, it would be marked wrong. So only put the formulas if you know it. Okay, if not, just saying large counts condition is fine for your formulas, and then you plug everything in to solve. Okay, so this would be 60 times P naught. What is P naught? What does P naught stand for?
Sample.
The claimed proportion. And what is the claimed proportion in our hypotheses? 0.8. This is P naught. Okay, so 60 times 0.8 is greater than or equal to 10. I agree. And then 60 times 1 minus 0.8 is greater than or equal to 10. I agree. You don't have to do any math there because they're going to be met. Okay. If not, you plug it into Desmos. 60 times 0.8, 60 times 0.2. Okay, now we're on calculate. And you see why I tell you to do the box? Because I'm out of room already. But it's okay. I can erase things. You guys can't. So for calculate, this is where you're going to need Desmos because I'm going to show you how to do this on Desmos. There's no need to do it by hand. Okay. So what I'm going to do first is I'm going to give you the steps for Desmos, and then we're going to continue our calculation section in our FRQ. Okay. So our steps for Desmos, that's what I'm going to write first, is we're first going to add an inference, and then we're going to click on proportion z-test. Okay. When we do this, it's going to ask for our number of successes and then our sample size. We get those from the problem. Okay. Then we're going to click on significance test. Okay. And then from there, we are going to put our p-naught value. And then it's going to give us our z-score and our p-value. Okay. So if I was setting this up, remember in Calculate, I have to first give the name. And this is a 1 proportion z-test. Okay. Since I'm using Desmos, I need to set up what that probability looks like. So this is the probability that z, and then whatever I put next is based on what my alternative hypothesis was. So my alternative hypothesis used what inequality? Less than. So less than, I'm going to use Desmos to find that z value, and this is going to be equal to my p-value. Okay, all of that's going to be on Desmos. I will not have to use any of the formulas. Okay, so let's go ahead and show that. Okay, so remember my first step is to add an inference. Okay, so hit the plus sign, click on inference, and then go to z-test for proportion. Is that the same as clicking on z-test? No, it's not the same. So click on z-test for proportion. And our successes and sample size can be found on how we set up p-hat. So successes is how many people said they had computers, which was what number? 41. And how many people did he sample? 60. So 41 for successes, 60 for sample size. Hit create tests. And which one are we talking about in this notes? Significance test. So hit that drop down. Okay. And look right here. It says null hypothesis is p equals, and that's where we put our p-naught value. So what number are we going to put there? 0.8. 0.8. Remember that 0.05 is alpha. That's different than p-naught. Okay. Then from here, notice that it gave us, okay, the next thing we're going to have to do is the tail. Okay, so the null hypothesis is p equals 0.8. The tail is telling us about our alternative hypothesis. So since alternative was less than, which tail am I looking at? The left. Okay, so from there, I'm given my z value and my p value. So what's my z value? Good, so I'm going to put negative 2.259. And what's my p value? 0.012. Okay, so once I write my inference name, which is the 1 proportion z-test, I follow the steps to figure out everything else for my calculate. Okay, so I'll follow those steps on Desmos. Okay, any questions before I move on to conclusion? Okay, so I'm going to close out a Desmos. Go back to this view. Okay, so now I'm on, if you divided it into boxes, on my last box, conclusion. Okay. And my conclusion, remember, I always use that sentence stem that's on the previous part of our notes. And it says, because our p-value, so I'm going to write that, because our p-value, and I write my p-value, so of 0.012, I'm literally following word for word of that sentence stem, okay, is, and then now I have to compare that p-value to what? Alpha. So remember, alpha was 0.05 and my p-value is 0.012. So is my p-value smaller or bigger? Smaller, right? So is smaller than alpha equal to 0.05. Because look at this. This is 0.05 and this is 0.01. So my p-value is smaller, okay? So if my p-value is smaller or if my p-value is low, we reject that host. So we say we reject the null hypothesis. And if we reject it, do we have convincing or do not have convincing? We have convincing evidence. So that's our first sentence. We reject the null hypothesis. Then we say we do have convincing evidence, okay, that the population proportion, let me shorten this a bit since I know you guys don't have a lot of space. Convincing evidence that the true proportion of students who have a computer is smaller than 0.8. Okay, so when I wrote my convincing or not convincing evidence part, this entire section here, so what did I color? Okay, green. This entire section here that says students who have a computer at home is smaller than 0.8, that is just me repeating my alternative hypothesis. So whatever you highlighted, your alternative hypothesis and communicate, highlight it the same color. Okay? And all I'm doing is taking that alternative hypothesis and writing it in words. So instead of saying P is less than 0.8, I say students who have a computer is smaller than 0.8. Okay. And that entire thing would be my FRQ. Okay. This last part of the notes, though, says interpret the p-value in context of the problem. This one right here is typically more of a multiple choice question. So an MCQ. Okay. And they have their own sentence stem for this one as well. Okay. So for this one, if we're interpreting the p-value, what is the p-value? 0.012. That's the p-value, the one we found. So we would say if the true proportion of students who have a computer is 80%, okay, then the probability of our sample, 41 out of 60, is 0.012. Okay, so notice where it says probability of our sample, and then I put 41 out of 60. That's my p-hat value. Okay, and so they're saying the probability of the p-hat value is going to be equal to our p-value, which makes sense because that's the definition of p-value. The definition of p-value is a conditional probability.